Hello, I'm Eric. I work on Pewter, this wonderful thing behind my face, with a focus on the back end. And in this video, I'm going to be talking about Pewter's boot sequence. The first thing we're going to do is launch it. It's going to take a little bit. I've got a lot of stuff open on my laptop and it's kind of struggling, but generally it flies. There we go. It's up. Pewter's boot sequence is documented in this markdown file, which you can find under source, backend, doc, contributors, bootsequence.md. The first phase of the boot sequence is setting up the runtime environment. This is when we determine where the configuration directory for Pewter is, where the runtime directory is, the mod directory, which was added recently, and then we instantiate all of the services. At this point, we're using a logger called bootLogger, which is later going to be replaced with the log services logger once the log service is ready. The next phase of the boot sequence is construction. This is when the construct method on all of the services is called, and services are able to set up any internal properties that they need to. After that is initialization. This is when we call the init method on all services, which is where a lot of the initialization of Pewter happens. And we can start registering things with other services that have set up data structures to register things into during the construction phase. For more complicated coordination between services, we need to wait until the consolidation phase when we start using the service event bus. And of course, this is when services prepare for the next phase, when they prepare to receive messages on the event bus. The next phase of the boot sequence is consolidation. This is when the boot.consolidation event is emitted on the service event bus, so services shouldn't use the event bus until this happens. And then services can perform coordinated setup behaviors. This isn't defined in any specific way in the boot sequence. It's up to the services which know something about the interface of other services, something about what those services expect. It's up to them to perform this in a way that makes sense. And services prepare for the next phase, which is activation. At activation is defined as the point when all of the blocking listeners for boot.consolidation have resolved, and the HTTP server starts listening at this point. Ready is the state when services are informed that Pewter is providing service. The web server has started, everything is ready, you can start your scheduled routines or anything like that at this point in time. The markdown file gets into further detail about each of these, saying the things that I've just said now, as well as some additional details about how this works. It also discusses events and asynchronous execution. The event bus we use, you'll recall I talked about blocking listeners. It has the ability for listeners to block the caller which emitted the event. The caller which emitted the event, of course, can choose whether or not to be blocked. It can use an asynchronous, immediately invoked function expression, something like that, and just continue doing what it needs to do. But it can be notified in this way when all the listeners have reported that they've performed the thing they need to perform. There's also a note here about legacy services. The boot sequence didn't always exist. It does now. Most of the services have been migrated. There's a few left over that still only implement an init method, and this init method needs to run after all the other services have run their init method. So that's enough of theory. let's get into the log messages and the code and see what's really going on. I've turned off the server and I'm going to scroll up the log output and we're going to find the first log message here. That was another instance of Pewter, so it must be down here. The first message we see is bootloader started. So if I go over here, we can find, I have the bootloader open. That's what it looks like. It's a class with some log functions, and it's created by Pewter's kernel. Pewter's kernel, just to go a step up, is started by this script. This is the script that's in the package JSON as the main script. So when you run npm start, this is the script that runs. And this script has a bunch of extra code to give nice error messages if you're using a obscenely outdated version of Node.js. And then it also instantiates the instance of the kernel class. Adds some modules to it. I'll talk about modules in a bit. And that's how we get here. It calls boot on the kernel. Boot on the kernel happens here. We do runtime init, and this is when we create the bootloader. Then the first thing we invoke after we create the bootloader is runtime environment. That is the first step of our boot sequence. This is the runtime environment class. The first method that gets called on it is init. We can see kernel calling init here. Init's wrapped in this try catch, and we're very careful to handle errors well and print nice error messages here, because most of the errors that someone's going to get when they try to run Pewter would presumably happen at boot or shortly after. The first thing we do in runtime environment is we figure out where everything is. We figure out where the config directory is, where the runtime directory is. It's called pwd directory here for process working directory. Where the mods path is, that was added recently. And after we've determined all of that, we change the process working directory to the runtime path that was determined. These are a little complex. For each of these directories, we go through a list of directories that might work, and there's a bunch of rules for when it's acceptable to use that directory. We can take a look at config, for example. In config paths, we first check the config path environment variable, and we check if that's undefined. If it's not undefined, we can use it. Otherwise, we skip on to /etc/pewter. If that exists, we use it. If it doesn't exist, we move on. And then if we're in the Pewter repository, this is where that check is, we can use volatile/config. This is typically what will happen when you run npm start. Is you won't have etc pewter, you won't have this environment variable set. It's going to create the config file in the volatile directory that's git keeped in the root of the repository. And that also holds true for the runtime path. It'll be volatile/runtime. And for mod paths, it will be the mods directory at the root of the repository, or some other specified location. So that was the config directory. Now we actually go and look for the right config file. That happens over here. And if there's no config file, we generate the config file. We generate a default configuration, and in order to generate a default configuration, we need to generate a random JWT secret and URL signature secret. So we do that, and then we create the default config. And then we load that. There's also an environment variable called Pewter config profile. You can actually have different config files, and then you can tell Pewter which one of those to run. And then the configuration file gets passed to the config loader, and then mods are sent back to the kernel. That's all the mod paths are used for here. We just format them properly and send them to the kernel, and then the kernel is going to proceed from there. So that is the entire runtime environment step. I'm going to clarify that configuration profile thing in a fresh clone. So I'm going to clone Pewter right now and npm install. I'm going to cd into the repository first, then I'll npm install. That took a little while, but it's done now. I'm going to list the contents of volatile/config, and we'll see that directory is empty. But once I run npm start, it's going to populate the default config again. So let's list the contents of the config directory. We can see it there now. I'm just going to display the contents. So we can see generated default config is the name of the configuration, and we have configuration for services as well. And I'm going to create a custom configuration directory. So this is actually the ideal way to do your configuration. Instead of updating the configuration file in here, create a new config called local.json as an example. I'm going to run an instance of VS Code here. I'm going to go to my configuration file. Whoops, that's not the one. You might find that your editor actually ignores the volatile directory because it's git ignored, so you'll have to manually go in there and get to the files. This is the default configuration that was generated when we ran Pewter, and I created another file here called local.json, and I changed one of the properties. If I wanted to change a property like services, this is an object in the original config, and I might want to preserve these values. So I actually added another meta property here called preserve. That'll just include over all of the properties from required JSON files. After we set up the runtime environment, hello, this is Eric from the future. My laptop rudely decided to cut out this piece of audio here while I was recording. Right now I'm going over the steps that happen after the runtime environment setup, and I'm talking about the console log manager here. The console log manager allows us to proxy all the console logs, which we need to redraw some things in the development console. And then we set up the services container, which contains all the services. And then a root context. A root context contains all the values that everything under this frame of execution is going to need. That includes the services container configuration and the logger, which right now is a boot logger, but we're replacing it later. And then we call these two methods, install modules and boot services, which I just found out aren't named correctly. Install modules actually also boots the services, and boot services starts the consolidation phase. So that will probably look a little bit different. If you're watching this video now, I've probably already changed that. Install modules starts by installing modules, and all a module really is this install method. A module implements install. Well, we can see that sticky at the top here, and it calls register service on the services container to add a bunch of services. That's what a module is. It's a collection of services. Then we call init on the services container. The services container, its init implements the iteration over the services to call first construct and then init after that. So that's the construction phase and the initialization phase. It's just two iterative method calls in the services container. Finally, in install modules, we resolve this promise, which is being awaited by boot services. And boot services is going to emit the consolidation event. So this is the consolidation phase. It calls await, so it's blocking on all blocking listeners. Or it's waiting for all blocking listeners. And then after that, it's going to call boot.activation. And it's also going to await all those listeners because once those listeners are done, it's going to emit boot.ready. Boot.ready happens when everything is done. That's at the very end. That is not a boot phase. That's boot is done. I'm going to finish this up by going through the log output and identifying the boot phases in the log output, because that seems like a fun thing to do, and it's also helpful to know that to follow along with the logs. The first thing we see is boot logger started, and then we see log messages when it's checking the configuration path and the runtime path. So we know this is the runtime environment phase. Last thing in that phase is it says the config name is local. That's the config I set. The next message we see is constructing util array. That's one of the libraries we have. Libraries that are services. Server health, log service, etc. So we're constructing all the services. And then somewhere here we start initializing all the services. And this might be my favorite part, is after we've initialized log service, all the log messages suddenly changed. Once log service is initialized, it replaces that logger value in the root context with its own logger, and then part way through initializing the services, we see the logging change, and the last service initialized. We'll see, because we're initializing, we'll see some things have logged that commands are being, or command service is logging that commands are registered. So that's one way you can see all the commands, I guess, other than typing the help command, which is an easier way to do that. And let's see. And this, I think, might be the last one. And then we start to see logs related to events. So this tells us we're in the consolidation phase. We're seeing, this is from the services container itself. It logs. There we have it, boot.consolidation as the first event. And then it proceeds to log some other events. And looking at these events can give you some idea of what happens during the consolidation phase as well. So there's a install middleware phase for context-aware middlewares. Context initializers get installed. Collections are registered to the registry, and then entries are added to those collections. The driver service says it's time to register interfaces if you want to do that. We install routes. There's the driver service again. Hey, install drivers if you want to do that. We install GUI routes. Those are a bit different. Those have to happen after the backend routes. And then we see boot.activation. So this means the consolidation phase is over. And we see the web server gets started at the activation phase, which makes sense. Then we see some of these cool logs here. Services are ready, server is ready, configuration mutated at runtime. It yells that at you because that can cause a lot of confusion if you don't know that that's happening. This is because of the auto port selection. That's why that happens. Then we install the WebSocket server. Web server is ready. There's just an event for that, for things that need to know that. And soon we should see the final event. We start seeing Webpack logs. In development, there's a Webpack watcher, and it logs every time a file changes. It also logs a lot at the beginning. So we see that. We see the server health service has done its first service check. We've refreshed the app cache because it's been running long enough now that that sort of thing is starting to happen. And we get the boot.ready event. At that point, we're done. That's the boot sequence. The Webpack watcher hasn't finished outputting all the stuff that it outputs. There's an alarm because this is a laptop and I don't have a lot of memory on it. And That's the bottom of the output. I turned the server off at some point so that it wouldn't overflow the buffer in my console with routine logs. And then we get the tip of the day, and we get Pewter is now live at this port. So that's Pewter's boot sequence.